morning, everyone. Hope you had a great week and a great weekend. I'm back at it again. We are trying to master electroporation, and what you'll see is this past week I have made many attempts. 4.5. 4.5 on the time constant. 0.7, that one did not work. Yes, good run. 4.1. Wow, it actually worked. 4.5. Excellent. 4.5. And have had quite a few successes in terms of running it. Now we're trying to make sure that I can get some good transformants on the plate so that we can move on. And one of the things that has happened a couple of times, and has happened with my most recent run, is I'm finding that I'm not getting any transformants directly on the middle of the plate. I'm actually seeing them along the edges. Now, I don't know if you can see on this particular one, see if I can get it lined just right. There's a single colony on this one right along the edge. But what's more telling is looking at a different plate, such as this one, which shows a lot of colonies, let's see if I can get it to focus, right there along the edge. So the question is, why do I keep getting all of these colonies along the edges? And to me, there's really two obvious choices that kind of jump out to me. One is that perhaps I'm not spreading the antibiotic evenly across the plate. It's very possible that when I spin the plate and turn it, this surface is uneven. You can't really tell, but it wobbles right here. And when I put the antibiotic solution on here, it tends to want to draw to one side. Even if I spread it with a plate spreader, it will still go to one side. And that's why you always see me move these to a flat surface to try to get them to dry evenly. And that would mean that those colonies that we see along the edges here are not actually transformed. They're just the E. coli recovering. And so I was thinking, like, how can I determine whether or not the colonies that I do see around the edges, whether or not those have actually been successfully transformed. And so one of the ways that I can do that is I can take a tube, I can put some LB broth in there, put some kanamycin in there, and then just pick the colony off and put it in the tube. And if I see the growth in the tube, that means that this was transformed, because only the transformed colonies will have the Spanish plasmid with kanamycin resistance in it. And so that's what I'm going to do right now, is I'm going to take 3 of these tubes and I'm going to put some LB broth in them with some kanamycin. And if I see that there's some outgrowth of the colonies that have grown along the outer edges of these plates, then that's great. That does confirm that the electroporation procedure is working, but it doesn't answer what's going on with my plate spreading technique. I've never had anybody teach me any of this stuff. Everything that I'm doing, I've learned just by reading and watching YouTube. And I'll be honest with you, I can't remember the last time I watched a YouTube channel, YouTube on how to do proper plate spreading. And I know that I use this little tool right here to spread things across the plate. But I know that there's other ways of spreading stuff on plates. They have beads. You can put the beads in the plate, and you can swish the beads around, and the beads will evenly distribute whatever it is that you want to put on the plate. So let me get those tubes going with the antibiotics and pick those colonies off, and let's see if we get any growth. If we do, that's great. That means the electroporation is working, and I just have a plate spreading problem. the 3 samples prepared with kanamycin, 1.5 microliters per tube, which is a little bit more than the 1 microliter per milliliter that we need, but that's okay. And they've been inoculated with a single colony from each of the plates that we're growing the colonies. So you can see how clear the broth is now. We're gonna go ahead and put this in the incubator for a couple of hours. And if they cloud over, then we know that our electroporation worked and we have a plate spreading problem, not a transformation issue. So let's give that a go and we'll check back and see what they look like in a couple of hours. All right, it's been a few hours. Let's take a look at our tubes. All right, guys, so I'm just testing these tubes that have kanamycin in it, and it looks like the middle one actually has some growth. I don't know if you can see that. When I tilt it, you can kind of see the turbulence in there, and that is bacterial outgrowth. Now, the top one and the bottom one don't have it, so that means the colonies for those plates were not kanamycin resistant, but the middle one was. And that's good because that means that our electroporation attempt worked, but we still have a couple of issues. So let's go over those issues and how we're gonna work to resolve them. As an additional test, I took the tube that was showing growth and spread it upon a plate that contained hygromycin, and here we see a nice lawn of growth. So this confirms that we did in fact have a successful transformation of the Spanish plasmid using electroporation. All right, so there's a lot of factors and variables that go into successful molecular biology experiments and electroporation in particular. And one of the things I want to point out is you're going to find lots of protocols. In fact, I have 3 in here for electroporation, and they're all 3 different. And they all vary on some pretty important aspects. For example, on this one, if you look right in the middle, you'll see it says electroporate at 1.8 kilovolts at 25 microfarads. Then if we turn to this other one, it says to use 1250 volts, which is 1.25 kilovolts. And then if we turn to the documentation that came with the electroparator, in fact, it even mentions DH5 alpha, and we look, it says to use 2.5 kilovolts. So we have 3 protocols calling for variable voltage ranging from about 1.2 kilovolts to 2.5 kilovolts. Luckily, everything else is the same, the capacitance in the pulse controller setting. But I have read that the higher the voltage, the higher the transformation rates. The other thing I want to mention is this particular paper, unlike the other protocols, actually calls for the final washing step to be done with 10% glycerol. And if you read, it says to reduce the ionic strength for higher voltage operation with the pulse controller, a 10% glycerol solution is now recommended. And so that is something that I actually, in my last few attempts, started doing. So I'm doing the normal washing step, but on the third and final, or actually rather the final suspension after the third washing step, I'm resuspending everything in a 10% glycerol solution. And so I think that's partially been what has helped me with running some of those electroporation attempts. But I think one of the things that I should be trying is to use a higher voltage setting. And so this one calls for 2.5 kilovolts. And I'll admit, I'm a little concerned that if I crank it up that high, I'm going to start getting a lot more arcing, which means that I have to do more work to prepare cells. But I think, and I have read for agrobacteria, it's also better to use a higher voltage as well. So that makes sense. One of the other things that I was thinking about with this issue that I'm having with my plates, not showing colonies in the middle and creating colonies around the edges, is one, my spreading technique. And I'll get to how we're going to test that in a moment. But the other thing that I've noticed is after you do the electroporation, so we put the cells in the cuvettes like this, and we pop them in here and we run them. Immediately what we need to do is, because if you can imagine, you can zoom in like at the magic school bus and zoom into the bottom where all those cells have just gotten shocked. You can imagine they're probably extremely hot. They just got a massive jolt of electricity fired through them in this case, 1.8 kilovolts or 1800 volts, and we're talking about cranking that up to 2.5 kilovolts. So the protocols call for immediately recovering these by adding 1 milliliter of LB broth to this, that you then suck up and put into a tube and then put into the incubator in order to recover those cells. And I have struggled from the beginning with getting the appropriate amount of LB media in these. One, because the pipetters don't really fit down into that small hole. So what I need to do is, and I've been using these very small pipettes to try to get the LB broth in here. And the thing is, we need, when we run this, there's probably not a lot of cells we're only putting 40 microliters of the dilute bacteria suspension in here. So when we run this with DNA, not all the cells are going to get transformed, only some of them will get transformed. So the point of recovery is to give them some fresh LB media, put them in the incubator and give them a chance to grow out and express the plasmid. And replicate, so that by the time we plate them, they don't just die when they immediately hit the kanamycin. So the other thing I noticed when I last did this and I did the recovery step was several of the tubes that I plated that we showed had no transformants on them didn't actually look like there was any outgrowth after a couple of hours. So something happened with those, even though they were successfully electroporated. Something happened between electroporating them, recovering them, and putting them in the incubator, because after a couple of hours, usually I can look in the tube and I can see that there was growth. But on the couple of ones that I plated, it didn't look like a whole lot had grown. However, the one that we tried today and we confirmed actually worked, that one actually did have some outgrowth. That was the number 4 here, and you can see how cloudy this is after a day. So this one actually had some transformants in it, and that's probably why when I plated it, there was at least one on there. So taking all that into account, we have a couple of things that we can work on and try to work on improving. One is I'm going to try to take one of these cuvettes, or I am going to take one of these cuvettes, and I'm going to once and for all sit down with one of these and just practice pipetting some LB broth in here, using different kinds of pipette tips and pipetters, and see if I can't figure out how to maximize my efficiency for recovery, and see if I can't find a technique that works reliably. Because if we don't fill that with fresh LB and then suck up any of the transformed cells, well, everything down the line is just not going to work. The other thing that I need to work on is my spreading technique, because having some of these which didn't have any successful transformants but showed some cells around the outer edge tells me that I'm not getting the kanamycin all the way around the edges. And that's not the end of the world, but it can cause false positives. And really what we want to see is, a plate full of colonies that have been transformed. And that's ultimately the final test of success on this. We'll test those two things, and then we'll go back to running our tests. We'll use glycerol, we'll use a higher voltage. So we have a lot of things we can try, a lot of variables, and we have much more work ahead of us, but we're making good progress and we're learning. And this is the process of DIY bio, especially if you're alone and you're just trying to figure things out. It's a ton of trial and error, but I'll tell you what, every single time I run this, I'm getting more comfortable with it. I'm getting better at it. We have a transformant. So now we're just working on optimizing it and cleaning up the rough edges. So let me get set up. I'll show you how I do some of the things, the troubleshooting things that we just talked about, and then we'll give it another go. Okay, now to test my plate spreading technique, what I'm going to do is take some red food coloring and add it to this little bit of water that I have. This is just regular water. Give this a little stir. I don't know if this is going to work, and I never have seen anyone do this before. So this will be kind of an interesting experiment. So normally I'll put somewhere between 150 and 250 microliters of whatever it is that I'm spreading. I'll put that onto the plate. Now, I think the more that you spread, the easier it is to get it evenly distributed, because there's just more material and more of it can soak in. So I'm going to start with less. I'm actually going to start with the 150 microliters. And this is a regular LB plate that's been sitting on my shelf for a little while. What's cool is you can kind of see like how my table is kind of uneven. Now, when I watched a couple of videos, this is the way that they said to do the spreading, is to kind of move this back and forth while turning it until it starts to feel kind of dry. Wow, this is really actually revealing a lot more than I would have thought. All right, let's take a look at that. First of all, I don't know if you can see this. See if I can get it a little bit closer. But where I originally put the stuff that I'm spreading, you can see how just a few seconds that it had to soak in, there's a heavier amount that is soaked into the plate here. I can tell you already too, just by like doing the spread, that not all of it has gotten around these edges. For whatever reason, oh, here's another interesting take. But for whatever reason, whenever I poured these, I noticed that there is a little bit of the media is kind of concave. And as a result, it's a little bit harder to get the spread, whatever it is you're spreading, up around these edges here. I'm trying to think like what have I what have I learned from this little experiment? Well, one, try to spread as quickly as possible so that there's less time for it to just soak in into one particular area. Two is I think like no matter what, it's going to be really difficult unless you have a high volume of whatever it is that you're spreading to get it up around this outer lip that keeps going up around the edges here. That being said, on my plates, I often notice some colonies around the outer edges and none in the middle. So I think when we're trying to get to confirming our transformants worked, what we really want to see is growth in the middle of the plate, because that will rule out the fact there might be colonies growing in an area where maybe the antibiotic didn't reach. Okay. The other really important thing that we want to work out is the recovery procedure. That is, after we put the cuvette into this little hole and we zap it, we actually need to put in some fresh LB media inside the cuvette with the freshly electroporated cells. And that's going to help cool them down and also begin to allow the cells to recover and begin to express the plasmid that was put into them. And I was actually reading that waiting over a minute, just over 60 seconds, will cause the transformation rates to halve, which is pretty incredible if you think about it. So that's why every time you read, they always encourage you to do the recovery as quickly as possible. So I need to figure out two things. One is, what's the maximum amount of media that I can put in these cuvettes? And two, what are the right tools for putting those in there? So let's go ahead and set ourselves up for a little experimentation here using water and trying a couple of different scenarios. For my first little test here, I have the new style cuvette. This is a 0.2 centimeter or 2 millimeter sized cuvette. These are the newest cuvettes that I have and what I'm going to be using for agrobacteria. And so all of the protocols I read say recover the electroporated cells with 1 milliliter of water. So let's go ahead and draw up LB media, but in our case, we're testing with water. So let's go ahead and draw up the 1 milliliter and let's settle this once for all. Can we fit a full milliliter of LB broth in here? Well, let's see. Well, look at that. Turns out you can. You see that? Okay, now can we draw all of that out is the other question. So the top part is easy. So you can see how much I got out, not quite all of it, probably half of it. So the question is, how do we get out that bottom amount? I saw one video where a guy leaned it like this, and that seems to be kind of working. but I think generally it looks like 1 microliter or 1 milliliter will fit. And also what's probably going to happen is the electroporated cells are going to get mixed in with this media. So even if I'm not able to draw up all of the media, some of the transformed cells will be mixed in with this stuff here that I draw back out. That was pretty good. So let's do a complete practice run here. Okay, beep, it zaps. We take the cuvette, take a microliter of LB bra, pipette that in there. Great, now we take it and we're gonna put it in a tube. And we're gonna turn it to the side. Well, I think we have figured out the best approach here, and that is to use a regular full-size pipetter. Putting 1 milliliter of recovery liquid or media in here does work, and we have to tilt it this way to draw out all of the media. And so we'll try using this technique the next time that we run our experiments.